In brilliant news for the open source AI space community, Cerebras System, who invented the warfare scale CS2 engine for the AI, has entered the AI race dominated by large language models. They have trained 7 models and is releasing them as Apache 2.0 licensed open source model. All 7 models were trained on the 16 CS2 Andromeda AI supercomputer, and the open source model can be fine-tuned and used for commercial purposes by anybody. These models range up to 13 billion parameters, and while they are smaller than the gargantuan 175 billion parameter GPT-3, but these Cerebras models are large enough to be useful for constrained domains such as finance, sports, specific technology, or politics. And also note that the accuracy of foundational models like this is not just a function of parameter size. The amount and the quality of the training data is as important as the number of parameters. So a 13 billion parameter model should be sufficient for many specific applications and knowledge sets. And Cerebras is sharing the models, weights, and training recipe via the most popular open source license, that is Apache 2.0 license. So the entire AI community now has a known good base to build the customized models for specific use cases and domains without paying a license to access the OpenAI API. Now let's quickly check the meaning of these Apache 2.0 license right here. So under the Apache license, users are permitted to modify, distribute, and sub-license the original open source code. Commercial use, warranties, and patent claims are also allowed with Apache license. The terms and conditions under the license don't place any restrictions on the code, but end users cannot hold the open source contributors liable for any reason. And further, Apache license versus another open source license, which is MIT license. What's the difference between them? So the Apache license and MIT license are broadly similar, but there are some key differences. For one, the Apache 2.0 license text is much more thorough and contain more legal terminology than the MIT license. The MIT license aims to be the most simple and straightforward open source license for developers to distribute their software under. Another key difference is that the Apache license requires developers to disclose any major changes they make to the original source code. The modified source code does not need to be revealed, but a notice of the modification is required. However, any unmodified code must retain the Apache license. And also, unlike the MIT license, open source software under the Apache license that has been modified is permitted to be patented by the end user as well. These patent rights are global, perpetual, irrevocable, and non-exclusive as long as the modified version does not suggest that it's endorsed by Apache in any way. The language of the Apache license makes the explicit grant of patent rights clear. Now, while releasing the model, they also published this blog beautifully describing some of the technical details here. So let's quickly go through this blog. Trained using Chinchilla formula, these models provide the highest accuracy for a given compute budget. Cerebras-GPT has faster training times, lower training cost, and consumes less energy than any publicly available model to date. In fact, Cerebras claims it only assigned a single engineer to train this model compared to some 35 engineers OpenAI used to build the distributed model to run across its GPU infrastructure. And the blog continues, today's release is designed to be used by and reproducible by anyone. All models, weights, and checkpoints are available on Hugging Face and GitHub under the Apache 2.0 license. And they have given some comparisons with other large language models. So OpenAI GPT is, of course, it's closed on very much every parameter here, and license is not available. Whereas Cerebras-GPT is open, architecture is open, training data open, model weights open, license Apache 2.0. Now compare that with Meta OPT, another very powerful one. This is open source absolutely, but the model weights are only available for researchers, and that also you have to apply with proper reasons given, and after a waiting period you will get that. And most importantly, Meta OPT is not for commercial use. You just cannot use their weights just like that for any commercial purpose. All right, now large language models can broadly categorized into two camps. The first group includes models such as OpenAI's GPT-4 and DeepMind's Chinchilla, which are trained on private data to achieve the highest level of accuracy. However, the trained weights and source code of these models are not available to the public. The second group includes models such as Meta's OPT and Eleuther's Pythia, which are open source but not trained in a compute optimal manner. By compute optimal, we refer to DeepMind's finding that large language models achieve the highest accuracy for a given fixed compute budget when 20 data tokens are used for every parameter in the model. Therefore, a 1 billion parameter model should be trained on 20 billion data tokens to reach optimal results for a fixed training budget. This is sometimes referred to as a Chinchilla recipe. So further on this point, they explain that an implication of this finding is that it's not optimal to use the same amount of training data when training a family of model sizes. For instance, training a small model with too much data results in diminishing returns and less accuracy gains per flop. It would be better to use a large model with less data. In contrast, a large model trained on too little data does not reach its potential. It would be better to reduce the model size and feed it more data. In each case, using 20 tokens per parameter is optimal as per the Chinchilla recipe. So Cerebras model is actually built following this Chinchilla recipe. So basically, actually, Cerebras-GPT is the first family of GPT models that are compute efficient at every model size. Existing OpenGPT models are trained on a fixed number of data tokens. By applying the Chinchilla training recipe across every model size, Cerebras-GPT sets a new high accuracy baseline for broad use. And about the performance of the Cerebras-GPT model, this is what they say. We evaluated the performance of Cerebras-GPT on several task-specific languages such as sentence completion and question and answer. We show that Cerebras-GPT preserves state-of-the-art training efficiency for most common downstream tasks, as shown in the examples in the graphs right here. So here these orange one is for Cerebras, right? Yeah, and they are giving different benchmarks that how they're performing, and as you can see, pretty much for all the benchmarks, it's absolutely right there on the top in terms of other SOTA models. And this is the Hugging Face page for all the 7 models of Cerebras. So you can see it starts right from 111 million parameter. And it goes up to the max, which is 13 billion. And if you go to the 13 billion model, you will get these 2 PyTorch model files. So both of them together is like a 48 GB file. So if you want to run it in your machine, be ready to download that kind of data. And also you need at least 24 GB of virtual RAM in your GPU. And around 64 GB of normal RAM, regular RAM in your machine as well. Alright, so here is an example code. I ran the 13 GB model here. And again, I have 3090, which has 24 GB of GPU RAM. And also I have 64 GB of RAM, normal regular RAM in my machine. So initially you just import your transformer and the regular modules, auto model for causal LM, that's what you need, and GPT-2 tokenizer. And then I'm defining a function just to load the model. So you run your auto model for causal lm.from pre-trained, and there you pass your model name, torch data type. I'm passing just float 16 here. Device map auto max memory I am setting it at 28 GB, and it kind of accommodated this model for a very simple inference case. And so your tokenizer will become GPT-2 tokenizer.from pre-trained, and from this method I'm just returning the model and the tokenizer. And then in the next cell I'm just defining the model name, which is Cerebras-GPT 13B, and execute this load model. It took almost 1.5 hours to download the entire 48 GB model into my machine, and I was running it in my local machine actually. And then I need to do the inference. So you just your inputs, you take the tokenizer, and to the tokenizer you pass. I'm passing single text as a question. What is capital of USA? And then with torch.inference mode, I actually do the inferencing here because I'm setting the inference mode right here. And then within these context, I have to use this model.generate. That's where the generation phase will start. And here you pass a bunch of configuration. That is how the model should generate. First argument is definitely the inputs. And then you pass use cache, which I'm setting it to true. So these use cache parameter in the generator, in the generate method of Hugging Face transformer library, controls whether or not the model's internal cache should be used during text generation. So when use cache is set to true, the model will use the cached values of the previous sequence generated to speed up the generation of subsequent sequences. This can be particularly useful when generating long sequences, as it can significantly reduce the amount of time required to generate each subsequent token. On the other hand, when use cache is set to false, the model will not use its internal cache and will instead generate each token in the sequence from scratch. This can be useful in situations where you want to ensure that the generated sequence is completely independent of any previously generated sequence. The default value of use cache is true, meaning that the model will use its internal cache by default during text generation. However, depending on your use case, you may want to experiment with setting use cache to false to see how it affects the quality and speed of the generated text. And then I'm setting the temperature to be 0.5, and the temperature parameter here is used to control the degree of randomness and creativity in the generated text. It determines the range of probabilities that are considered when selecting the next word in the generated text. A lower temperature will result in the model generated more conservative and predictive text, while a higher temperature will lead to a more creative and diverse output, but with a higher likelihood of generating nonsensical or irrelevant text. So the temperature parameter is usually set to a value between 0 and 1, with 1 being the default value. A temperature of 0, if you set it at right at 0, that would result in the model always generating the same output, while a very high temperature, for example maybe 10 or 12, would result in the model generating extremely diverse and unpredictable output. And then I give some other parameters, for example, no repeat n-gram size, repetition penalty, which will determine the penalty for repetition at 1, max new token 128, and finally I need to decode the tokenizer. So I do tokenizer.decode, and within that you pass your completion.squeeze and print the output. And what's my output? That's my output. What is the capital of USA? That was the input, and the output is the capital of United States of America is Washington DC. So yeah, for this super simple use case, the 13 billion parameter worked really well. But of course, the true power of this model will come when you fine-tune it on your custom dataset. And because it's Apache 2.0 license, you can also use the result for commercial use. So really, this is a pretty sensational development in this space, and really sky is the limit what you can do with this model.